In question number 5, it says you have radio collars that are used to track polar bear, and we have receiving stations A and B 9 kilometers apart on a road. So that's what I've drawn here. We have the two receiving stations at A and B being 9 kilometers apart, and it says that the signal comes to A at 49 degrees, and over at B, the signal comes at 65 degrees, and these are measured from standard position. Okay, so that's why I've drawn these little black crosses here to indicate the axes to measure standard position. So I want to find the distance each one of these is from the distance the polar bear is from each of these tracking stations. To do this, this is a non-right triangle, so we're going to try to use sine law here. To use sine law, we need opposite angle and side pairs. So the only side I've been given is 9 kilometers, so I need the opposite side, the opposite angle theta. To get that opposite angle theta, I'm going to have to work out some of the angles inside the triangle. So using the standard position of 65 degrees here, I know supplementary angle here adds up to 180 degrees. So this must be 115 degrees. From using that angle then, we can work out angle theta. When I add those angles together, subtract it from 180 degrees, I get 16 degrees. Okay, so once I've established that, I can set up a sine law ratio that allows me to calculate the length of D1 and D2. So to use sine law, we need to pair up angle and opposite side. So I'm going to do that with the 9 kilometers. I'm just going to do that over here. So the 9 kilometers over the sine of 16 degrees. That ratio is going to be equivalent to, and I'm going to solve for D1 first. So it's going to be the length D1 over sine of 115 degrees. And I can solve this algebraically. So I get D1 is equal to 9 times sine of 115 degrees over sine of 16 degrees. Okay, at this point I'm just going to calculate in my calculator. So plugging this in, 9 sine 115 divided by sine of 16 degrees, and that's going to give me, let's see here, it's going to give me 29.59. Okay, so it's going to give me a length of 29.59 kilometers. So that's going to be my D1 length. Okay, so I'm just going to write that in here, equals 29.59 kilometers. So D2, we do the same thing, except this case here, we're going to set this up the same ratio, 9 over sine 16 degrees. That's going to be equal to D2 over sine of, in this case here, that's going to be 49 degrees. Okay, so there's my ratio solving for D2. So D2 is equal to 9 sine of 49 degrees over sine 16 degrees, and putting that into my calculator, I end up with 24.64 kilometers. Okay, so that's my D2 length. Okay, and I'm just putting that into my diagram here. This D2 length is 24.64 kilometers.